Welcome to another tutorial of Proflan YouTube channel. In this video, we are going to look at IGCSE Physics 0625 Cambridge, and we are going to look at the topic of waves, such that we can be able to see how do you approach different questions that are asked in this particular topic. And if you are new to Proflan YouTube channel, consider subscribing so that anytime I'm going to upload more tutorials, you'll be notified. So we're going to start here. If you are going to do the exam, this video is for you so that you can be able to prepare on the topic waves as far as refraction and light waves and all types of wave, general properties of waves is concerned. The first question that we are asked here is to state the speed of light in air. Light travels at the speed of 3 times 10 raised power 8 or 300 million. So anytime you are asked speed of light in air, that is basically what you're going to say. A refractive index of water is 1.3. Calculate the speed of light in water. So what you ought to remember at this given point is that refractive index can be calculated from the formula speed of light in a vacuum over the speed of light in the material. So if we rearrange this, because we are working out the speed of light in water, we are going to have speed of light in a vacuum or air over the refractive index that was given there. So that is going to be 3 times 10 raised power 8 divided by 1.3, and that is going to give us 2.3 times 10 raised power 8 meters per second. Second question is whereby candidates were told to state the part of the electromagnetic spectrum that transfer thermal energy. Basically, that is infrared. And this is the section whereby you need to understand that hot objects, they give heat energy. They give out infrared radiations. In this topic of electromagnetic spectrum, you need to understand common properties of all the waves, and also you need to understand differences. In the event you are asked to state common properties, you are going to say all the waves are transverse in nature, all the waves, they travel at the speed of light, all the way they undergo reflection, refraction, and also diffraction. So that is when you are asked common properties. But in the event you are asked to state differences, you will talk of different wavelength and different frequencies. So always remember that, guys. We need to move to the next part. In which way, in one way, you state one way in which visible light is different from or is similar to the wave that you stated in the previous section. You stated infrared radiation. You can see that. Then if you are asked similarities, both are transverse waves, both visible and infrared, both reflect and refract. So those are the similarities that you ought really to mention in that case. But if you are told to state differences or the way they differ or the way they are different, you are going to say visible light has a higher frequency than infrared, or visible light has a shorter wavelength compared to infrared. Also, you can say you just talk of differences in terms of wavelength and differences in terms of frequency, guys. The next bit is whereby you are supposed to match each the radio and the electromagnetic radiation that is used. For instance, radio, they use radio waves. Remote controls, they use infrared. Yeah. If we are talking of binoculars, you cannot be able to use a binoculars if there is no visible light, guys. So that's what you need to remember there. And also, if we are talking of sunbeds, that one is, and you use what we call what? Ultraviolet light. Yeah. Sometimes you may be given a question whereby you are supposed to complete the waves after they pass through the gap. How are they going to emerge out? So if the gap is almost equal to the wavelength, if the gap that you are having here is a small gap, the waves are going to emerge as circular waves. That's why you can see here they are circular. And this process is called diffraction. And you need to understand that diffraction is the spreading of a wave after it has passed through a gap or it has passed through a boundary. Then we are supposed to state also the effect of increasing the gap. The effect of increasing this gap. In fact, what you need to realize here, if we try to increase the gap, this is exactly what's going to happen. Now, for instance, if we were having this wave here and the gap now increases, let's say the gap becomes bigger like that. The gap becomes bigger like that. So these waves are going to emerge as straight waves which are bending at the edges. They will emerge as straight waves which are bending at the edges, meaning there will be less diffraction if you increase the gap. But if the gap is small, you are going to have very sharp and bigger extent of diffraction, and then the waves are going to emerge as circular waves. State the effect of increasing the width, then we are going to say diffraction, there will be less diffraction, or the waves are going to emerge as straight waves bending at the edges. Explain the effect of decreasing the wavelength. In fact, if we decrease the wavelength, this will increase the if we decrease the frequency, rather, this is going to decrease. That's going to increase the wavelength. If you decrease the frequency, you are going to decrease the wavelength because the speed has to remain the same. So if the speed has to remain the same and you have decreased the frequency, then the wavelength has to increase. Yeah. So if you are supposed to draw, you are told, draw line to show each of the statement, correct? So change in direction of light entering a medium, that is refraction. Very high frequency sounds, those are ultrasounds. Very low frequency sounds are infrasound or infrasonic sounds. Glass prisms producing spectrum, that is dispersion. If light passes through a glass prism, then the light is going to be separated into different colors, and that is what we call diffraction. Light spreading after passing an obstacle, a gap, that is diffraction. But the sound reflecting from a wall, that is an echo. And 7 colors of light, that is the spectrum. Yeah, so basically, if you are given a question like that, that's exactly what you are going to do. In this question here, we are told a loudspeaker is built into the side built into the sides of a swimming pool. The loudspeaker produces sound waves and the water waves of length 0.25 meters. Then we have letra majogon. So anytime you are told to state the speed of light of sound in air. Speed of sound in air is between 300 and 360. So you can give a value in between there. But speed of sound in water is up approximately 1,500. Speed of sound in solids is approximately 5,000 meters per second. So anytime you're given a question, you need to know those approximations. For solids, 5,000. For liquids, around 1,500. But for air, speed of sound in air is between 300 to 360. So always remember that. State and explain for the sound produced by loudspeaker how the wavelength of sound in air compares to the wavelength of sound in water. Because sound travels faster in water, the wavelength is going to be large, but in air the wavelength is going to be short. So it becomes shorter because water waves travels shorter distances. Yeah. Anytime you are asked about when a wave is moving from water in a deeper region to a shallow region, you need to understand that the wave is going to slow down. If a wave slows down, it means that that wave is going to bend towards the normal, and the direction of that water wave is going to vary like that. So since that wave travels at a slower speed or a lower speed, the wave fronts here are going to be closer than this one here. This one, the wave fronts or the wavelength longer, or the separation of the lines is larger. Here the separation of the lines is going to be a bit shorter, and this is called refraction, as water waves are moving from one medium to another. In this question here, you are told that the critical angle of water is 48 degrees. If the critical angle is 48, so anytime you have an angle greater than 48, then we are going to have what we call total internal reflection taking place. But here there will be refraction, there will be also refraction at this point. But since this angle is bigger, it is 40 degrees and this is 20 degrees, then there will be a larger angle of incidence here compared to this one. So you have to ensure when you are drawing the lines after refraction, this one will bend more because of this angle being greater than this one. The next question candidates were asked is to define what we call the critical angle, and you need to understand that critical angle is the angle of incidence when the angle of refraction is more than when the angle of refraction is 90 degrees. At this point, there is no light emerging on the other end, so what's happening here is total internal reflection. But here we are having the angle of incidence being around 30 degrees, because if this is 60 and this is the normal, this being the normal, then the angle remaining to make it 90 is 30. So the angle of incidence is 30, which is less than the critical angle, which is 42. So meaning total internal reflection will not take place here. Here total internal reflection will take place because the angle of incidence is 45. So the angle of reflection will be 45 as well. So light would be undergoing total internal reflection. But here the angle of incidence is less than the critical angle, so there will be no total internal reflection. We shall have reflection and also refraction at the same point. This is an optical fiber which is usually used for communication, and also it's used as an endoscope in hospitals. So you can be asked, whenever you are asked the application or the use of this optical fiber, you can say it's used in hospitals and as an endoscope to see internal structures or inner parts of the body such as stomach, and also can be able to be used in communication because information can be sent in form of infrared or visible light, and it's transmitted through the optical fiber, and that is used in communication. You need also to understand the relationship between sine critical angle and the refractive index, so that anytime you are asked to work out the critical angle, you can do that. For instance, in this question here, we are told to calculate the critical angle. Since we are given the refractive index, we can say sine of 1 over n, sine c is equals to 1 over n, and that means you can say sine c is equals to 1 over 1.46, and then you can be able to find the sine inverse, because anytime you want to find an angle, you do the sine inverse of that, and that is going to give us 43 degrees. In this question also, we are told what? We are told that on the diagram, state the value of labeled P. Because there is total internal reflection taking place here, if this is 62, this is also going to be 62. And as the light is going to emerge out of this, remember when light is moving from a denser medium to a less dense medium, glass is dense. So as it's getting into air, light is going to speed up. And when light speeds up, it's going to bend away from the normal, and that is what we call refraction. State the name of the process that takes place at B. That is total internal reflection. And lastly, we have this section here, whereby you are supposed to identify the dotted line. The dotted line is making 90 degrees with the boundary, and that is called the normal. And you are asked to identify the angle of incidence, the angle of refraction. Remember, this light is moving from air into glass. So this angle here at the top here is called angle of incidence, but the angle below here is called the angle of refraction. So don't confuse. This is the angle of incidence, and the angle inside the medium as light is moving from air into glass, that is called the angle of refraction, which is 29 degrees.